Friends, imagine this. Your power transformer is running. Load looks normal. Temperatures are okay. No alarms, no trips. But inside the oil, hydrogen is silently increasing. No smoke, no fire, no visible fault. Yet this one gas alone can tell you. Insulation stress, partial discharge, low energy arcing, or the very first warning before a catastrophic failure. Most engineers see hydrogen in the DGA report and either ignore it or misinterpret it. And that single mistake has destroyed transformers worth millions. So today, in Electroverse, we will decode hydrogen in DGA. Why hydrogen forms inside transformer oil. What type of faults it truly represents. How to read hydrogen trends correctly. When hydrogen is harmless. And when hydrogen is a serious red flag. Plus, real-world interpretation logic used by senior engineers. By the end of this video, you will never look at a DGA report the same way again. Stay with me till the end. Because hydrogen never lies. Only engineers misread it.
In the world of power transformers, there's one gas that speaks before all others: hydrogen. It's the earliest warning signal, the first whisper of trouble, and something that can save a transformer long before it fails. If you truly understand hydrogen, you understand early transformer warnings. Hydrogen, or H₂, is the lightest and fastest forming gas inside transformer oil. When electrical stress begins to develop within a transformer, hydrogen is the first gas to appear. It forms primarily due to electrical stress, such as partial discharge or corona activity, rather than high temperature conditions. This makes it fundamentally different from other gases that typically indicate thermal faults. According to IEC 6599 and IEEE C₄H₆.104, hydrogen is considered an early fault indicator. These international standards have established clear concentration limits that help engineers interpret what hydrogen levels mean for transformer health. The standard limits define three distinct zones. Normal operation shows hydrogen below 50 parts per million. The caution zone ranges from 50 to 150 parts per million, and the alarm zone indicates hydrogen above 150 parts per million. When hydrogen is reported as limited, which means less than detection, that's actually a healthy sign. It indicates your transformer has no active electrical stress and is operating within normal parameters. This is the ideal state every engineer wants to see in their DGA reports. But here's where real engineering judgment starts. When hydrogen begins to rise, you need to understand what it's telling you. There are two critical scenarios every engineer must recognize. First, increasing hydrogen with zero acetylene and low ethylene. This pattern indicates insulation stress or partial discharge activity. It's not an immediate shutdown condition, but it must be monitored closely. The transformer is telling you that something has started, but it's still early. The second scenario is far more serious. Rapidly increasing hydrogen alongside acetylene. This is serious. This indicates arcing and requires immediate investigation. When you see this combination, you're looking at high energy electrical activity that can quickly escalate to catastrophic failure. The key engineering actions when hydrogen crosses standard limits include increasing your DGA sampling frequency from quarterly to monthly. You need to prioritize trend analysis over single values, because hydrogen's behavior over time tells the real story. A stable elevated reading is very different from a rapidly climbing trend. For rising hydrogen levels, further investigation should include partial discharge testing, bushing condition review, and checking earthing systems. These are the most common sources of electrical stress that generate hydrogen. Remember, avoid panic shutdowns. Hydrogen is a diagnostic gas, not a trip signal. It's designed to give you time to investigate and plan corrective action. Good engineers monitor, great engineers interpret trends. DGA is not about one gas. It's about patterns. Hydrogen alone provides early warning, but hydrogen with acetylene becomes a danger signal. Understanding this distinction can mean the difference between planned maintenance and emergency outages. The formation mechanism of hydrogen is crucial to understand. Unlike thermal gases that require high temperatures, hydrogen forms at relatively low energy levels. Even minor electrical stress can begin hydrogen production. This sensitivity makes it invaluable for early detection, but it also means you need to interpret results carefully within the context of your specific transformer's operating conditions. Modern DGA interpretation requires analyzing hydrogen in conjunction with other gases to identify fault patterns. The ratio methods defined in IEC and IEEE standards help distinguish between different types of electrical and thermal faults. But remember, these are guidelines, not absolute rules. Your engineering experience and understanding of the specific transformer's history remain essential. Hydrogen is the earliest voice of a transformer. It whispers before the transformer screams. If you listen early, you prevent failures, outages, and asset loss. This early warning capability makes hydrogen monitoring one of the most valuable tools in transformer asset management. When you understand hydrogen's message, you gain the power to act before problems become critical, ensuring reliable power delivery and protecting valuable transformer assets.
So friends, this is the real science behind hydrogen in transformer DGA. Not just numbers, not just limits, but meaning. Remember this one golden rule. Hydrogen is not the fault. Hydrogen is the messenger. It tells you how insulation is behaving, how electrical stress is developing, and whether a hidden problem is slowly growing. If you read hydrogen correctly, you don't react in panic. You act with confidence. If this explanation helped you think like a senior transformer engineer, then support Electroverse. Like this video, share it with engineers who deal with DGA reports. Comment below. What was your highest hydrogen value ever seen? And subscribe, because upcoming videos will decode methane, ethylene, acetylene, CO, CO2, one by one, in depth. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.